This last section, we're not going to actually perform partial fraction decomposition. You'll do that shortly in your pre-calculus algebra class. But we're just going to talk about some of the things that you will need to know for partial fraction decomposition. First of all, what is partial fraction decomposition? Well, it's where you take a fraction with variables and all in it, and you split it up, okay? So like this may be equal to, I really don't know, I don't know if that's the answer or not, so don't quote me there. But you can see how it's been split up. We're actually undoing adding or subtracting. So we would have added or subtracted, gotten a common denominator, and gotten to this point. Now we need to undo that. And you'll find out why that's important if you take calculus. So, find the polynomial in this denominator, it says. Or factor the polynomial in this denominator. So the denominator is x squared minus x plus 6. If we want to factor that, what multiplies to give us 6, that adds to give us negative 1. Let's see, 3 and 2, the 3 would have to be negative. And it says determine if they are distinct linear factors, repeated linear factors, or irreducible quadratic factors. So what's the difference? Well, linear factors would be in the form mx plus b. These are linear factors, 1x minus 3 and 1x plus 2. Repeated would mean they were the same, or we had a squared here or something, okay? So these are not repeated, and they are linear factors. So we say that they are distinct linear factors. An irreducible quadratic factor, by the way, would look something like x squared plus 1, okay? That is something that cannot be factored, and it's quadratic. That would be an irreducible quadratic factor. This example says, determine if the partial fraction decomposition is correct. Now, how would we determine if they're correct? Well, we would determine if they're correct by taking this, getting common denominators, and actually adding them back together. So, how would we get a common denominator here? Well, our common denominator would need to be these three factors multiplied, right? So it'd need to be x minus 1 times x plus 1 times x minus 2. With something on the top. We'll figure that out in a minute. So how are we going to get there? Well, if we have 2 over x minus 1, what do we need to multiply that by to get x minus 1 times x plus 1 times x minus 2 on the bottom? Well, we've already got x minus 1 on the bottom here, so we need to multiply by x plus 1 and x minus 2. But if we multiply the bottom by that, we have to multiply the top by the same thing. And then we have 1 over x plus 1. Well, here we have x plus 1 on the bottom, so we need to multiply by x minus 1 and x minus 2. And same thing on the top. And then we have 3 over x minus 2. So the x minus 2 is already on the bottom. We need to multiply by x plus 1 and x minus 1. So, on the top, it's going to be a lot bigger than I have room for there. So, let's get to work on that. So, we have 2 times x plus 1 times x minus 2 over x minus 1 times x plus 1 times x minus 2. And then we have 1 times x minus 1 times x minus 2 over x minus 1 times x plus 1 times x minus 2. And last, we have 3 times x plus 1 times x minus 1 over x minus 1 times x plus 1 times x minus 2. Okay. I think I'm going to run out of room here. Now, let's see. Since we've got the denominator all the same, then we can put just 1x minus 1 times x plus 1 times x minus 2 on the bottom. And then I'm going to go through and full things on top. So x plus 1 times x minus 2 is x squared minus x minus 2. X minus 1 times x minus 2 is x squared minus 3x plus 2. And x minus 1, or x plus 1 times x minus 1 is x squared minus 1. Distribute the 2 and then the 3. So we'll have 2x squared minus 2x minus 4. Like I said, I'm going to run out of room, so I'm going to have to erase and move things up here. I should have added another page. Okay. And then we just have x squared minus 3x plus 2 and distribute the 3. So 3x squared minus 3. All over x minus 1 times x plus 1 times x minus 2. And then just simplify. So 2x squared plus x squared plus 3x squared. 2 plus 1 plus 3 is 6x squared. Negative 2x minus 3x is negative 5x. And then negative 4 plus 2 minus 3 is negative 5. Oops. Let me go back here and let's do the bottom. So first, x minus 1 times x plus 1. Full that, and you're going to get x squared minus 1. And then full this, you'll get x cubed minus 2x squared minus x plus 2. Now we can ask ourselves, is that? And yes, it is. So we determined that the partial fraction decomposition for this problem is correct. That concludes this section. No, it doesn't. I forgot. There's another example. Oops. Okay. The last example and the last set of problems you'll be looking at ask us, can the partial fraction decomposition be decomposed further? So basically, what it's asking is, can the bottoms of these fractions be factored any further? If they can, then we could continue with the partial fraction decomposition. If they can't be factored, then we could not continue. So x plus 3 is obviously already factored. We need to look at x squared minus 2x minus 8 and decide, will that factor? So let's see. 4 and 2 would give us 8. If we make the 4 negative and the 2 positive, that would multiply to be negative 8 and add to be negative 2. So it does factor. So what we're going to say is, yes, we can factor further. And now that concludes this section.